Welcome to our Glory Globe TV viewers. Breaking news, yes, magnetization by laser pulse. A futuristic twist in material science, the new invention, right? To magnetize an iron nail, one simply has to stroke its surface several times with a bar magnet. Yet, there is a much more unusual method. A team led by the Holz, Gentharam, Dresden, Rosenrob discovered some time ago that a certain iron alloy can be magnetized. The ultra-short laser pulses. The researchers have now teamed up with a laser institute Hochschule Mittweida investigate this process further. They discovered that phenomenon also occurs with a different class of materials which significantly broadens potential application prospects. The working group presents its findings in the scientific journal Advanced Functional Materials. Breakthrough discovery in magnetization. Yes, the unexpected discovery was made back in 2018 when the HZDR team irradiated a thin layer of an iron-aluminum alloy with ultra-short laser pulses. The non-magnetic material suddenly became magnetic. The explanation: the laser pulses rearrange the atoms in the crystal in such a way that the iron atoms move closer together and thus forming magnet. The researchers were then able to demagnetize the layer again with a series of weaker laser pulses. This enabled them to discover a way of creating and erasing teeny magnetic spots on a surface. However, the pilot experiment still left some questions unanswered. It was unclear whether the effect only occurs in the iron-aluminum alloy or also in other materials. Explained HZDR's physicist Dr. Rantech Bali, who, he also wanted to try tracking the time progression of the process. For further investigation, he teamed up with Dr. Theo Flack from the LHM and colleges from the University of Zaragoza in Spain. The expert focused specifically on an iron vanadium alloy. Unlike the iron aluminum alloy with its regular crystal lattice, the atom in the iron vanadium alloy are arranged more chaotically, forming an amorphous glass-like structure. In order to observe what happens upon laser irradiation, the physicists used a special method, the pump probe method. First, they irradiate the alloy with a strong laser pulse which magnetizes the material, explains Theo Flack. Simultaneously, we use a second weaker pulse that is reflected on the material surface. The analysis of the reflected laser pulse provides an indication of the material's physical properties. This process is repeated several times, whereby the time interval between the first pump pulse and the subsequent probe pulse is continually extended. As a result, a time series of reflection data is obtained which allows to characterize the processes being triggered by the laser extinction and also the excitation. The whole procedure is similar, generating a flip book, says Flack. Likewise, a series of individual images that animate when viewed in quick succession. The result, although it was a different atomic structure than the iron-aluminum compound, the iron-vanadium alloy can also magnetize via laser. In both cases, the material melts briefly at the irradiation point, explained Rantech Bali. This caused the laser to erase the previous structures so that a small magnetic area is generated in both alloys. An encouraging result. Apparently, the phenomenon is not limited to a specific material structure but can be observed in diverse atomic arrangement. The team is also keeping track of the temporal dynamics of the process. At least we know in which timescale something happens, explains Theo Flack. Within femtoseconds, the laser pulse excites the electrons in the material. Several picoseconds later, the excited electron transfers their energy to the atomic nuclei. Consequently, this energy transfer causes the rearrangement into a magnetic structure which is stabilized by the subsequent rapid cooling. In follow-up experiments, the researchers aim to observe exactly how the atoms rearrange themselves by examining the magnetization processes with intense X-rays. Beyond the report, Glory Globe TV.